This video clip is part of the EPFL introductory course on information, computing, and communication. It is the fourth one in a set of video clips on memory hierarchies and management. It explains how a two-level hierarchy combination of cache and main memory operates. Logically, the processor sees the cache-main memory combination as an array of so-called words, where words are typically 4 or 8 bytes long, meaning 32 or 64 bits. Every word is identified by a sequential number, called its address in main memory, which ranges between 0 and n, where n is the size of the main memory. To read or write a word in memory, the processor gives the memory a read or write command, together with the address of the word that it wants to read or write. When a word must be read, the memory sends the value of its content back to the processor. When a word must be written, the processor must provide the memory with the value to be written into the given word in memory. Physically, things are a bit more complicated, however, since the memory really consists of two levels, the cache and the main memory, and the processor can access information only in the cache, not directly in the main memory. Between the processor and the cache, information is transferred in words, as suggested so far. Internally, however, cache and main memory are organized into blocks, where blocks are typically several words long, 4 words in this example, and the data transfer between cache and main memory happens in blocks, not in words. Thus, while main memory latency is slower than the cache, in the case of this example, it provides 4 times as much information at a time upon every single access. Now, in order for this to work, the cache must of course always know which words and thus which blocks it contains. For this purpose, the cache is built as a so-called associative memory. This means that each block that it contains is flagged with an additional few bits indicating the address of the first word in that block.